The overall goal of this procedure is to manufacture a large volume of self-assembling lipid-based oxygen microbubbles, or LOMs, for intravenous oxygen delivery. This is accomplished using a high-shear homogenizer and a gas-tight tank to manufacture and serially concentrate LOMs. The second step is to use modified syringes to extrude an LOM emulsion containing 70 volume% oxygen. Next, the emulsion is concentrated by centrifugation to yield a 90 volume% oxygen foam. The final step is to perform quality control by calculating volume% oxygen and assessing the particle size distribution using light scattering technology. Ultimately, high-shear homogenization produces 2 liters of LOMs containing 90% oxygen by volume.
The main advantage of this technique over existing manufacturing methods like sonication and amalgamation is that homogenization produces self-assembling microbubbles on the order of liters, a volume necessary for large animal testing of therapeutic oxygen delivery.
One of the uses of this technique is to treat patients with hypoxemia, because oxygen gas-filled microbubbles transfer oxygen to deoxyhemoglobin within seconds and carry 3 times the oxygen content of blood.
Visual demonstration of this method is important as the depth of the homogenizer head, the maintenance of a purely oxygenated environment, and the discernment of concentrated LOMs versus the aqueous phase can be difficult to appreciate.
The system for manufacturing lipid